Okay guys, here are your Unit 3 notes. The topic is experimentation. Sorry. Because my throat is so sore, I'm trying to do this one time instead of 3 times today and 2 times tomorrow. So take notes just like you normally would if I was up and speaking in front of the class, and we will make it work. The cool thing about this is if I go too fast for you, which I likely will, you can just pause it and then replay it or something like that, and just pause the screen until you get the stuff written down. Those of you that have had lots of science classes before, you probably are aware of these, a lot of these terms. You probably heard these things before. Um, if not, that's okay. But we're going to go through each one of them today and get all the way through them and talk about them. So, without any further ado, here we go. Maybe. Okay, your first word is hypothesis. This is a word you probably all heard before. A hypothesis is an educated guess that can be tested for accuracy. Please remember to take notes over these things or get them down. If you know something forwards and backwards, you know the word hypothesis, you're never going to miss the word hypothesis, don't write it down. But a lot of these are going to be new to you, and you're going to want to get them down. And the other thing is, please, please, please use your pause button so you can write, because I'm going to go a little bit faster. Okay, hypothesis, educated guess that can be tested for accuracy. The next one is a survey. You've all taken surveys before, you know what a survey is, but a survey is just where people are asked a series of questions about a particular subject. It can be serious and very official, like the census that only takes place every 10 years. Or it could be a survey of how many of you would rather have, cheese pizza at lunch rather than pepperoni pizza or whatever. Okay. All right, your target population is the whole group that you want to study or describe. Okay, the target population is the whole group of people you want to study or describe. If I were to do an experiment here at school, I could say my target population is all Winnetonka High School students as of the date 10/14/13. Okay, all Winnetonka students would be my target population. Now, if I were to do a experiment or a survey or something one day, one time, chances are I would not reach my entire target population. You're going to have kids out of school today. You have people absent, you have people sick, whatever. Okay? So the target population is absolutely everyone. Because I cannot probably get everyone, my best option is to get a sample. A sample is just part of the target population. Although there are two different types of samples, I still need to pull out part of the target population since I likely cannot get every single person on any given day. So I could do a random sample. Let's say there's 1,500 kids at our school, which isn't quite right, but let's say there are. Every person's name goes in the drawing one time, and I decide that I'm going to pull out 150 kids out of our 1,500, so I get a good percentage of our population. So that would be a random sample. Individuals are selected by chance. Nobody has a greater chance than anyone else of getting drawn. It's just completely random. I'm going to pull out the first 150 names. That's my target, or excuse me, that's my sample, my random sample. I could also do a stratified sample, which can be very useful at times. A stratified sample is where your subgroups in the population are represented proportionally to the sample. So, let's say here at Winnetonka we have 51% female students, 49% male. Let's say we have 70% Caucasian students. We have 15% African American. We have 10% Hispanic. And we have 3% Asian or Pacific Islanders, and then 2% other, just other. Okay? Hopefully that equals 100. You'd have to go back and add it up again. But anyways, if I was looking for a stratified sample, out of my 150 people that I'm choosing from my target population, which is all Winnetonka students, I would want my subgroup to match that exactly. So I would want, let's see if I can remember what I said. Out of my 150 students, I would want 51% female, 49% male. I would want 70% Caucasian, 15% African American, 10% Hispanic, 2% Asian or Pacific Islander, or 3% Asian or Pacific Islander, 2% other. I would want all of that shown for an accurate stratified sample. Okay, the next terms are longitudinal method, a longitudinal study. The word longitudinal has the word long in it, so you know that it takes a long time. Okay? It's a select group of participants that are observed over a period of time, often years or decades. So you are going to look at the same people for years or decades. This takes a lot of time, it takes a lot of money, it takes a lot of follow-up. Often the researchers start as adults, and so if you're studying children, it's possible that your participants in your study could outlive you. So this is a difficult way to do things for sure. As we do this, none of you will be completing longitudinal studies, so please don't say that you did, because you did not. So basically, if I want to see what the percentage of people, or what the connection is, correlation between babies that are born with spina bifida, which is a problem that we only get in infancy, but then we are able to correct here in America. We're blessed with that medical knowledge. But if I were to look at the correlation between babies that get spina bifida and adults that get Parkinson's, I have to look at the exact same group of kids. I have to look at kids with spina bifida and wait until they are older adults to find out if they get Parkinson's. I cannot look at babies with spina bifida and adults with Parkinson's at the same time that are not the same people. I have to watch the same people for this to be a true study. Now, that's difficult, that's expensive, that's time consuming. So a lot of people are going to do a cross-sectional method. Cross-sectional means I'm going to observe people at different ages in order to avoid the same issues that I just mentioned in the longitudinal studies. So, if I want to talk about the growth rate or language development from ages 2 to 10, language development from ages 2 to 10, I could look at a group of, and maybe I'm comparing low socioeconomic to higher socioeconomic children. So I could look at low socioeconomic kids at age 2. I could look at high socioeconomic kids at age 2. I could study them. Then I'd take different kids and I look at low socioeconomic at age 4, high socioeconomic at age 4. Next one. Low socioeconomic at age 6, high at age 6, age 8, age 10. I can look at all of that cross-sectionally, and it's going to take me 1 year to do my study rather than waiting the full 8 years to do my entire study and then start processing my results. The next one is a naturalistic observation, which in some cases is the right thing to do. Naturalistic is pretty simple to understand. It's observing people in their natural environment. If I wanted to see how you did on a particular test, if I wanted to know, what your circumstances were on the test, I would prefer to do it in a naturalistic setting, meaning I give you a test in your classroom where you normally sit. If I want artificial results, I'll move you to sit somewhere else. I'll stick you in a different classroom and see how that goes. I'm not going to get the same results as if you are in your natural environment. I had a student one year as part of this project that you guys are going to be doing. She was a lifeguard, and she decided that her experiment was going to be to see how people would react to finding a wallet. And so she put an empty wallet on the pool deck, and she observed what people would do. She watched some people pick it up and kind of sneak it. She watched some people walk it right over to her. She watched some people open it first and do all kinds of different things with it. So in a naturalistic setting, she is getting to see exactly what people would do. Whereas if she were to sit those same people down and say, what would you do if you found a wallet at your local gym? What would be your first course of action? A lot of them would say, oh, I'd just turn it right in. I'd take it to the lifeguard. I'd take it to the front desk, whatever. But she got to actually see what they would actually do in a naturalistic environment. Now, a laboratory observation is another way to do things, and this could be good too. This is observing people in a laboratory setting or controlled setting. When you do a laboratory observation, you are managing all the variables. Every person in that study has this exact same environment, which isn't necessarily a bad thing. Every person has the same lighting, every person has the same temperature, every person has the same chair, the same desk, the same teacher, the same whatever that you're looking at. They all have the same thing. So you're taking out all of the other variables. If you were to look at people in naturalistic observations, maybe you're getting a bunch of different variables. You got wind, you got temperature, you got lighting, whatever. So there is something good to be said for the laboratory observation as well. The next is correlation, and this is a word you may already have from your definitions from Unit 1, our vocab unit. Correlation is just the relationship between variables. Okay, that's pretty simple, the relationship between variables. But there are positive and negative correlations. Positive and negative correlations. And positive in this case does not mean good, and negative does not mean bad. Positive does not mean up, and negative does not mean down. They can be any variety of things. Positive correlation are any two variables that travel in the same direction, either up, up, or down, down. Negative correlation, they're going to travel in opposite directions, so up, down, or down, up. Now let me give you an example. If I am looking at an infant, I'm going to say there is a positive correlation between an infant's age and their weight. Because for a long time, for years, as a baby gets older, they get heavier. That's just how it works until we start to taper off as we get a little bit older. Okay? So that's an up-up positive correlation situation. Okay? A negative correlation would be not necessarily a bad thing. Let's say the amount of cardiovascular exercise that I do, so the amount of time I actually spend running, things like that, my weight would go down, or my blood pressure would go down. So that's one variable going up, the amount of time I spend working out, and my the other variable going down, my weight, my blood pressure, things like that. Okay, so please don't confuse positive with ups and good things, and negatives with down and bad things. They can be either. An experiment is kind of the key to this whole thing. An experiment is the method that researchers use to answer questions about cause and effect. If you want to know what happens if you want to know what happens when, if you want to know why does that happen, you do an experiment. You set up an experiment to figure it out. Experiments can be anything, really. You can experiment with anything. So if you want to know what the answer to your question is, then you set up an experiment. Variables are anything that can change, or something that can change. It doesn't necessarily change, but it's something that can change. And there's two key types of variables, independent and dependent, and many of you have heard of these before. An independent variable is a factor that researchers change to determine its effect. So it's the thing that the researcher, or you, actually change. If I'm trying to find out which type of soil makes, or what effect different types of soil has on the growth of a soybean, I'm changing the different types of soil. I'm going to put one in there with topsoil. I'm going to put one in there with dirt I just dug out of the ground. I'm going to put one with generic potting soil, maybe one with Miracle-Gro, True Green, things like that. Okay, so now I have 5 independent variables, 5 things that I'm changing to determine the effect on the soybean. Okay, you guys all probably did an experiment like that when you were younger. The dependent variable is the thing that changes because of the independent variable. So in this case, it would be the growth of the soybean. The growth of the soybean is being affected by what type of soil we're using. We have to assume that the lighting is the same for everybody, that the water intake is the same for all the different types of soil. We're going to treat everything else the same, but what I'm changing is the soil, and that's the independent variable. What I'm watching change is the growth of the soybean. That's the dependent variable. Okay, so independent variable is what we change. Dependent is what changes because of us. The experimental group are the participants in the experiment that receive the treatment. So for example, if we're talking about our soybean experiment here, the topsoil, the Miracle-Gro, the True Green, and I don't remember what the other one I said was. Anyways, the generic potting soil, that's what it is. Those are all the experimental groups. Okay, those are the ones that are receiving different types of treatment, different types of soil than a soybean would normally receive. That's our experimental group. Whereas our control group is going to be the 1 cup with a soybean in it that has actual soil that I just dug out of the ground in it. Okay, that's the participant that is not receiving the treatment. The one that is the control. Okay, the control group does not receive the treatment. A controlled experiment is an experiment in which you have a control group and an experimental group. So as you're doing your project, if you use a control group and an experimental group, please say that you used a controlled experiment. Now the next word is one that you may not know how to pronounce it. You may have seen it before, you may have even heard it, but not necessarily know what it is. The word is placebo. Placebo. It's a substance or treatment that has no effect except for a person's belief in it, which is kind of an interesting phenomenon. A placebo has no real medical or otherwise no effect whatsoever in real life, but a person might believe that they're taking a medicine and then their actions might begin to change because of those things. So a placebo could be this. We have a new medicine, it's a new focus medicine, and everybody wants to take this new great focus medicine. So come sign up for our new focus medicine treatment. And so they get all these people to sign up, they test them, okay, are you ready? And then they give out half of the participants, they're going to give them the real new focus medication. They're going to give them the real thing, and they're going to say, okay, keep a journal, tell us how you did, tell us about your focus. The other half, they're going to give a placebo, they're going to give a fake medication and say, okay, here's the real thing, enjoy it, keep a journal, let us know how it goes, tell us about your focus, and come back to us in 2 weeks. And everybody's going to come back in 2 weeks, and they're going to compare everybody's results together, to the people who got the real treatment and the people who got the placebo treatment, and then they'll have an accurate understanding of what their medication is actually doing. Is it really helping people focus, or is it just people want to focus more or think that they can on this new brilliant medication? Another kind of funny placebo story. My psychology teacher told me this one. Colorado State University, their psychology department did a big study one day, and they had a party, and they said, okay, come to our party, and you can't drive out of here. Get on a bus, come to the big house out here, whatever, and we're gonna have, pay $5 and you can get, beer or whatever, and everybody will stay the night, and we'll make sure you get back to your dorms tomorrow, and we'll just have a big party. So there's music playing, everybody's drinking, stuff like that. And what they had not been told is that the beer was non-alcoholic. All the beer that in the kegs that they were drinking, all of it was non-alcoholic. So they were essentially having a placebo. But they didn't realize it. Not everyone realized it. Some people were starting to come up to the hosts and saying, hey, what's going on, whatever. And they're like, okay, just, they dismissed those people kind of quietly, let them get out of there because they realized they weren't feeling anything or whatever. Well, that didn't happen with everybody. One girl in particular got her picture taken dancing on a table with like a lampshade on her head or something like that. And that was the front page of the newspaper the next morning with the headline, partygoers drink fake beer. Well, she made a fool of herself. She, had taken her shirt off and all kinds of, stupid stuff like that. She wasn't the only one that was acting drunk or making poor excuses for their behavior, making out with somebody or something like that they maybe normally wouldn't have. They were using themselves being drunk as an excuse for this behavior, but they weren't drunk. It was a placebo the whole time. So kind of crazy. And that happened at Colorado State University a number of years ago, but kind of interesting. Okay, moving on. A single blind study is where participants do not know if they are part of the control group or the experimental group. That's really important. If you had told all of these people that some of you will be drinking real beer and some of you will be drinking fake beer, if you had told all of the focus pill people, some of you will get the real medicine, some of you will get the fake medicine, they wouldn't know. You'd get different results. Okay? You have to not know if you're part of the control group or the experimental group. Now, a double-blind study is where neither the participants nor the researchers are aware of who has received the treatment. So the results are much more true. It's a little bit more difficult because you have to have a third-party person who keeps track of everything. But the study that can be done in a double-blind study is usually a lot more accurate because there's no bias whatsoever. I don't know if any of you guys are Grey's Anatomy fans, but Grey's Anatomy had a thing a few seasons ago. They got to do an Alzheimer's research thing. Derek was in charge of it, and the chief's wife was going to be a part of it. Well, they would actually like cut open the brain and implant something into the head of these Alzheimer's patients, and half of the participants had a placebo, and half of them had the real treatment. And Meredith cheated. She was the third party that was supposed to look at the double blind, or supposed to help with the double blind study. She was the only one that was supposed to know if it was a placebo or the real thing. And she found out that the chief's wife was getting the placebo, and so she tried to change the results. But anyways, that was supposed to be a double blind study. Now that takes us to the next piece, which is ethics. This is a word that can be used in any setting, not just in experimentation. But ethics are your standards for proper and responsible behavior. Standards for proper and responsible behavior. Okay, you have a personal code of ethics. Your workplace has a code of ethics. Your school has a code of ethics. Standards for proper and responsible behavior. But it's very important that in your experimentation that you are being ethical. We'll talk about some examples of that later, but you need to be ethical as you perform your experiment. The next one is informed consent, and we're winding down here, just a couple more words to write down. Informed consent means that people must agree to participate in the study. They have to know what you are studying, they have to have heard an overview, and then be given a choice whether or not to participate. You cannot force people to participate in your study. All of the people on all of the Brain Games DVDs that we watched, they all had informed consent. They were all told, you were going to be part of a National Geographic show on studying memory or studying mirror neurons, like the people who got their hand hit with a hammer. You can't just hit somebody's hand with a hammer and not ask them about it first. Okay, even if it's fake hand, you can't just do that. So you have to tell people what they are being studied for without giving too much away. You don't have to tell them if there's a placebo. You don't have to tell them what part of if they're part of the control group or the experimental group, but they have to know what you're studying and have a choice whether or not they would like to participate. Okay, so it's very important, and as you start thinking about what you want to do for your experiment, that you make sure you have informed consent. And lastly is confidentiality. This is oh so important. When you do an experiment or a treatment, even if you're not taking it seriously, like the one you're probably going to do for our class, it might not be real scientific. But you have to respect the privacy and confidentiality of all participants. You cannot use real names. You cannot use telling factors about the participant. For example, you couldn't say, teacher JP wearing the KU shirt in the front of the room. Well, everybody would know who that is. Every single person in this room would be able to tell who that is. You have to use things, participant A, participant 223, things like that, things that nobody could figure out. You can't use initials. You can't use telling factors about them. You can't describe people too much. You have to be factual and not funny in your results. So as we perform our experiments, you must be confidential. I do not want to know who the test was on. I do not want to know anything like that, because that, one, it affects your results, and two, it affects my view of the validity of your project. Okay? And the last thing is just kind of the scientific, you don't need to copy, there's no chart for you to copy down, but just the scientific method of experimentation and observation. You should know the scientific method. You form a question, form a hypothesis, test your hypothesis, analyze your results, draw a conclusion, and in many cases you end up retesting as well. You don't necessarily need to write this slide down, just some information for you to have. Okay, so we will do more practice with all of this coming up. We will test your understanding of these words and make sure that you get it all figured out. But ultimately, we are done with our vocab for today. And so I'll go back to the list. Sorry, I have to click through like this. I'll go back to the overall list and leave you with that. If there's anything that you missed from today, please go back, rewatch it, figure it out. But here's all the different words that you learned today and all the words that you are responsible for knowing for this unit. Thanks.